All right, here's another recursion example where we're finding odd sum. So we're gonna have an input n, and we want to find the sum of all the odd numbers from 1 up to that n. So if n was 7, we'd want to do 7 plus 5 plus 3 plus 1, 16. If it was 9, we'd want to do 9 plus 7 plus 5 plus 3 plus 1. Okay, so we want to do a method. We can actually do the heading right here. So we can just do public static, it's going to return an int of find odd sum. Okay, and we're going to take in an integer n that represents the highest odd number in the sum. Okay, and when you do this, I would think of it in two cases, the base case and then the recursive step. Okay, so I'm going to flip back to the other screen here, but see if you can figure out, I always do the base case first. Like, what's the most basic sum that you think we would do? All right, and so the answer to that is right here, right? So if they pass in 1, we don't have to work backwards or anything. We just return 1. Okay, so in our base case, I'm going to do if n equals 1, then I just want to return 1, right? If they pass in 1, the odd sum is just 1. Okay, and then I'm going to put my recursive step in my else. Okay, so recursive step, just make it one step simpler. Okay, so I'm going to go back to, and we look here, that basically what we've got to recognize is that when we're doing find odd sum 9, this right here is really find odd sum of 7. So that if I wanted to break up find odd sum of 9, right, if I did that one step simpler, that would really be like a 9 plus find odd sum 7, right? Because again, that's what this is right here, right? So that is 9 plus find odd sum 7. Okay, in a similar way, if I needed to do, say, find odd sum of 11, all right, that would just be, I could do 11 plus use find, right? It would do 11, I could plus 9 plus 7, blah, 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 but I don't need to do that part because 9 plus 7 plus 5 plus 3 plus 1 is find odd sum 9, right? So I can just replace all of this with, instead of all the parts, just recalling the method, right, which is find odd sum 9. Okay, so now all we need to do is do the generic version of this. So if I want to do find odd sum of n, okay, we know that n is not 1, it's not the base case, right? But what would it look like here? What would the two parts be? Okay, and so the answer to this is it would be n itself plus find odd sum of n minus 2, right? So when it was 11, we did 11 plus 2 less than 11. When it was 9, we did 9 plus 2 less than 9. Okay, so that's what I'm going to return. So I'm going to go in here. Instead of returning an actual value, I'm going to return whatever n is, plus I'm going to recall the method with n minus 2. All right, so let's give this a shot, see if we can call it. So instead of factorial, I'm going to call my find odd sum. Find odd sum. I'm going to pass in 9. And I'm going to see, I forget what it should be. I think it was like 25. Does that look right? Yeah, 25. So we could try another one. Maybe if we did 11, that should be 36 would be my guess. Because it'd be 11 more than find odd sum 9. So if we get 36 there. Okay, so it seems to be working just fine. Okay, so it looks pretty simple, right? There's just two parts, the base case and the recursive step that's going to recall the method. Right? And the recursive step, you always recall it with one step simpler. So n got smaller here. That's why it doesn't go on forever and ever, because it goes smaller, smaller, smaller until n is 1, and then it stops. All right, last example I want to cover on day 1 here is these things called triangle numbers, right? So our input to the method is going to be n, and then the output is going to be the total number of circles made in that triangle. So for triangle 1, it's 1, triangle 2 is 3, triangle 3, 6, triangle 4 is 10. Okay, but the cool part or the interesting part about this recursively is triangle 4. So if I called like the method triangle 4, that really is like this bottom row of 4, right, plus this blue part is triangle 3, right? If I kind of do all of this, that's triangle 3, the number of circles that are in picture 3, right? This blue is exactly the same as that. So I could break it down then to 4 times whatever number of circles are in triangle of 3. Okay, and similarly, triangle of 3 then, right? Triangle of 3 would just be 3, this extra row, plus triangle 2, right? These 3 right here are triangle 2. So it'd be 3 plus triangle 2. Sorry for the bad handwriting there. Okay, and then triangle 2 would just be 2, the bottom red row here, plus triangle of 1. Okay, and then triangle of 1 is just 1. Okay, so once you have triangle 1, it's 1, then this becomes 3, and then triangle 3 becomes 6, then triangle 4 would be 4 plus 6, 10. So we'd go all the way down to the base case and then come back up. So again, there's just 2 parts, the base case and the recursive call. Okay, so we'll try to think through what are those 2 cases before we start to do the code. Okay, so the base case is n equals 1, and we just want to return 1. So the basic picture, and n is 1, and we just have 1 circle in that picture. Okay, and then the recursive case. So in this case, we want to return, let's see, n, like this bottom row was 4 for picture 4, right? So for 4, we did 4 plus triangle 3. For 3, we did 3 plus triangle 2. So I'm just going to want to return whatever n is plus triangle method of, let's see, 1 less than n. All right, we're going 1 step simpler, right? So again, I just think of an example here, like 4 is number 4, n4 is 4 plus triangle 3. So for n it was 4, it was 4 plus triangle 3, 1 less than 4. So it's whatever n is plus the triangle method, 1 less than that. All right, so now we just got to type up that method. Right, and it's going to look very, very much like the other one. So I'm going to do public static. I'm returning an int. I'm just going to call it triangle with an input of n. Okay, and then it's just the 2 base cases again. So if n equals 1, then it's going to return 1 because in picture 1 there was just 1 circle. Otherwise, this is the recursive step, and I want to make it 1 step simpler. So I'm going to return whatever n was plus recall the method, right? That's what makes it recursive, with 1 less than n. So I'm going to return n plus the triangle method 1 less than that. And again, it'll just keep calling it back and back and back and back until it hits the base case, and then it'll do all the sums back up. So here's a picture of it again. Once it gets to triangle 1, it finally returns 1, and then it goes back up the call tree so it can finish triangle 4. Right, so here triangle 4 really doesn't finish until triangle 3 finishes. Triangle 3 doesn't finish till triangle 2 does. Triangle 2 doesn't finish until triangle 1 finishes, and once it finishes, then it calls it back up. So it kind of pops back up. They call it sometimes the stack trace. It pops back up and goes up the tree from there. All right, so let's see. The 4th picture was 10, so let's try triangle of 4 and see if we actually get 10. Kind of like bowling pins, actually. And so if we added a 5th one, it should be 15. Right, the 5th triangle number would be 15 because we'd have a row of 5 at the bottom. Right, if we think about it visually, we'd have a row of 5 down here. All right, so that's it. Seems to be working just fine. All right, and then again, that's all it is. It's got a base case and then a recursive step that makes it 1 step simpler by recalling the method. All right, hopefully that makes sense. As always, reach out if you have questions. Thanks for watching.